Okay, this video is going to go over section 7.7. The topic is called solving right triangles. So you will see these directions throughout some of your problems. And so when we solve a right triangle, we want to find all the missing parts. So that's actually what I have here at the beginning. So to solve a right triangle, you determine the measures of all 6 parts of the triangle. So think about having 3 angles and 3 sides. So this includes the hypotenuse and both legs. Here are the 3 sides and the 3 angles. All right. So you want to find all the missing pieces. So you will be given some of that information, but some you will need. Okay, so I want to actually do an example with you to help you kind of understand how to do this. So I want you to draw here over to the side. I'd like you to draw a 30, 60, 90 triangle. So I'm going to do a longer leg, a shorter leg, and a hypotenuse. So let's see, that means my 30 is at the top because your smallest angle is opposite your shortest leg. So I'm going to add onto my diagram the hypotenuse. Let's call that 10 units long, and let's put an X here on the 30. So based on what we just talked about, I have here from 30, I have the opposite leg and the adjacent, I'm sorry, that's not right, that's the hypotenuse. I have the opposite leg and the hypotenuse. So I still am thinking about SOHCAHTOA. So S-O-H, so, ka, C-A-H, toa. So I have labeled the O and the H. I have labeled the sine part of my ratio. So if I were to solve this out, I could say the sine of 30 degrees equals opposite x, or hypotenuse is 10. So then if I go ahead and cross multiply and solve, I'm doing x equals 10 times the sine of 30 degrees. 10 times the sine of 30, and I get 5. So I want to go back and remind you about the 30, 60, 90 rules. So I could have bypassed all this. So short leg, hypotenuse. So to go from short to hypotenuse, we double it. So we want to divide by 2 to go backwards. All right, so that's the whole reason for having those rules, is because it's a much quicker process. Now I can certainly go through this and get the same answer. Okay, let's say we had this. Let's redraw your 30, 60, 90. But we are going to pretend we don't know it's a 30, 60, 90. And we're going to use 10 as our hypotenuse and 5 as one of the legs. So what if I have this and I want to find one of the acute angles? I could do Pythagorean theorem to get my third side, but I want one of these angles. So we're going to do what's called an inverse sine, cosine, or tangent. Okay, so let me come back to that in a minute. Okay, we're going to let ABC be a right triangle. You can solve the triangle if you know either 2 side lengths or 1 side length and 1 acute angle measure. So I want you to see these 3 items. If the sine of an angle is x, then this is called the inverse sine of x is the measure of the angle. So when you see that, this is what I want you to say in your mind. I don't want you to say sine to the -1 power. I want you to say the inverse sine is the measure of the angle. So relate that to this. I know that the sine of 30 is equal to 5 because I know it's x over 10, and so the sine of 30 got me 5. So x is equal to 5. Let me back up. That's not correct. The sine of 30 is equal to 5 over 10. Okay? So that means if I do the inverse sine of 5 over 10, I get the angle. Okay, so let me show you what I mean down here. So I want to find the measure. I'm going to put, let's just call this angle A. So I want to find the measure of angle A. So I am going to still do SOHCAHTOA. From angle A, 5 is my opposite, 10 is my hypotenuse. So opposite over hypotenuse goes with sine. So I know that the sine of A, I don't know A yet, is equal to 5 over 10. Okay, so to get angle A, if I do the inverse sine of what it's equal to, I will get a degree measure. So on your calculator, above sine, cosine, and tangent are the inverses. See the inverse right there, above sine, inverse, and inverse. So we need to do second to get there. So if I type this in, I go second the sine. See how it says inverse sine? And I'm just going to type it in as like that. 5 divided by 10 is the same as 5/10. Okay? I could reduce it to 1/2 if I wanted to. When I hit equal, look how I get 30. So that means I got a 30-degree angle for A. Now, I knew that was 30 because we just kind of did the opposite up here. So I just want you to see the relationship to that. So the sine of, when I knew angle A was 30, the sine of 30 is a number over 10, and we got 5 here, so it's 5 over 10. So if I don't know it's 30, if I do the inverse sine of the opposite over a hypotenuse, it tells me the angle measure. So the 3 inverses create the angles. So if I want just a side length, I'm doing regular sine, cosine, tangent. If I want an angle measure, I'm doing inverse. So number 1 here, let's start by approximating angles. So I'm going to use a calculator to approximate the measure of angle X to the nearest 1/10 of a degree. So I like to put a dot on the angle I need to use. So from angle X, my 7 is opposite, my 5 is adjacent, and I like to just still put hypotenuse on there just to make sure I didn't mix up, you know, adjacent and hypotenuse. All right, so now I'm looking at 5 and 7, A and O. SOHCAHTOA says I want the tangent ratio, TOA. So I'm going to start by saying that the tangent of X is equal to opposite over adjacent. So 7 over 5. So in order to get the angle measure, I'm going to do the inverse tangent of that ratio. Okay, so if I knew the angle, the ratio of 7 over, I would calculate either 7 or 5, but this time I'm going to do the inverse. So I'm going to go second tangent, there's my inverse, and like I said, I'm just going to type it in. I mean, you can do a fraction, okay, but I don't typically do that because sometimes the calculator, it doesn't like having the various symbols within the tangent. So I just write it or type it in as a fraction. 7 divided by 5 is 7/5. I don't do any decimals here. Like 7 divided by 5, so this would have been okay, 1.4. But if you have a decimal that is repeating, like say it's a third, if I type in 0.3, it'll give me a different angle measure than if I type in 1/3 because it's not precise. So the inverse tangent of 7/5, so I'm rounding to the nearest 1/10 of a degree. This is a degree measure. So I got 54.5 degrees. Okay. So inverse tangent will give us degrees. All right, number 2. Let A and B be acute angles in a right triangle. Use a calculator to approximate the measure of A and B to the nearest 1/10 of a degree. So I need a visual here. Draw a right triangle. So A and B are the 2 acute angles. So it doesn't matter exactly where A and B go, but it can't go on the 90 because 90 is not acute. Okay, so from this picture, the sine of A it equals 0.19. All right, so this has been divided out for me. So instead of leaving it like a fraction, it's just turned into a decimal. So if I want to do the angle measure, I need to do the inverse sine of this. So the inverse sine of 0.19 will give me the measure of angle A. So the measure of angle A let's see. So inverse sine 0.19 gives me about a 10.95, does it say? Okay, nearest 10th. So that's going to force me to round it to 11.0. I'll just put 11.0. That kind of shows me that I did some rounding. So if I want the measure of angle B, if this is 90 and this is 11, well, I can just use the triangle sum theorem to calculate the missing angle. So I could take 180 minus the 11. I get 169, and then minus the 90, 79. Or I know that A and B also add up to 90, so I really could just take 90 minus 11 to get my 79. Okay, either way you look at it is fine. Or I guess 79.0 maybe would be in line with what I have up there. Move the degree. Okay, cosine of B. So the cosine of B is 0.56. So if I do the inverse cosine of 0.56, that will give me the measure of angle B, since it's designated with B. So cosine of 0.56 is 55.9. So that's the measure of angle B. So the measure of angle B is 55.9 degrees. And so I want to know what the measure of angle A is. So it's complementary with that other angle. So I get 34.1. Okay, so the measure of angle B, 55.9, and then A is 34.1. Okay, let's move on. All right, I want you to take a look at number 3 here. So the directions tell me to solve the right triangle. So I want to go ahead and round everything to nearest tenth. So I'll get some decimals here. All right, so solving the right triangle means find the missing pieces. So let's talk about angles. I know D, I need angle E. So let me make a list over here for a second. You need the measure of angle E, and then you're missing 2 side lengths. You need the length of DF and the length of DE. Okay, measure of angle E. So don't overthink this. If you have 2 angles in a triangle, find the third. All right, I don't need to do like an inverse sine, cosine, or tangent. I'm just going to figure out the third. So 90 minus 37, because these 2 also add up to 90, gives me 53. So the measure of angle E is 53 degrees. Okay. So now I need DF. All right, so maybe I'm going to go ahead and put an X here. Okay, from 37, so now I need SOHCAHTOA. SOHCAHTOA. So from 37, I've got opposite, I've got adjacent, and I'll go ahead and put H for hypotenuse. Okay, so I have information on the O and the A, that is tangent. So the tangent of the degree measure of 37 degrees equals O over A, so 14 over X. If you make a proportion, we can cross multiply. So I'm going to have 14 equals X times tangent of 37 degrees. Solve for X, remember, that's just a number. So divide off the number, divide off the tangent of 37 on both sides. Okay, these guys cancel. So I get 14 divided by tangent of 37, and I get about 18.6. Okay, so that's DF. So DF is 18.6. Now I need DE. So I'm going to call that side Y, and I'm going to do another trigonometric function. So I am working with 37. I'm not going to use this number because I rounded that, and I don't want to plug a rounded number into an equation and then have to round again. It won't be as precise. So I'm going to focus on 14, opposite. My Y is hypotenuse. O, opposite and hypotenuse goes with sine. So I'm going to set up a sine function. So the sine of 37 degrees equals opposite 14 over hypotenuse. You could call it h if you want. I picked y. So again, cross multiply. So 14 equals y times the sine of 37. And then now I can divide off the sine of 37. All right. So here's kind of a little trick here on these calculators. I'm going to go up and put my cursor on tangent. If I type sine, look at what it does. It just goes over it. So now I'm doing, and I just double check, 14 divided by sine of 37. So y is approximately 23.3, and that is DE. So DE equals 23.3. Okay, so I have solved the right triangle. I know all 6 pieces. All right, I want you to pause the video, and I want you to do example 4. I'm going to actually stop the video, and then in the next video I will go through solutions here, and I think, yeah, we have a couple more examples. So try A and B, and when you're ready, go to the next video.